The transformation didn't happen by accident. It happened because one man refused to accept that ships had to be built the way they'd always been built. Henry J. Kaiser was 60 years old in 1941. He'd spent his career building things: roads, dams, bridges. He'd been part of the consortium that constructed Hoover Dam, Bonneville Dam, and Grand Coulee Dam. He knew construction. He knew concrete and steel. He knew logistics and labor management. But he'd never built a ship. That was precisely why he saw what traditional shipbuilders couldn't see. In December 1940, Kaiser and two partners won a contract to build 30 cargo ships for the British government, which was already at war and losing vessels to U-boats faster than they could be replaced. For the project, Kaiser established his first shipyard in Richmond, California. Traditional shipbuilders looked at the contract and saw 30 ships that would take 2 or 3 years to complete using conventional methods. Kaiser looked at it and saw an assembly line problem. He'd watched automobile production transform from craft work to industrial scale. He'd seen how breaking complex products into subassemblies and using standardized parts could speed production exponentially. Ships were just bigger automobiles. Vastly bigger, infinitely more complex, but built from the same principles: steel components, mechanical systems, assembly sequences. If Ford could build cars on moving assembly lines, why couldn't ships be built the same way? The first challenge was the design. The British had ordered ocean-class freighters, simple but fairly large vessels with a 2,500 horsepower compound steam engine. Britain specified coal-fired plants because it had extensive coal mines, but no significant domestic oil production at the time. The design was basic, deliberately so. It used older technology that was reliable, rather than cutting-edge equipment that might fail. The U.S. Maritime Commission took that British design and modified it to American standards. They changed the power plant to oil-fired boilers, which were more common in American shipbuilding. They designated the modified design EC2SC1, emergency cargo, 2 for a ship between 400 and 450 feet long, S for steam engines, and C1 for design C1. Most importantly, they changed the construction method from riveting to welding. Riveting accounted for 1/3 of labor costs in traditional shipbuilding. It required skilled craftsmen who could precisely set rivets to hold steel plates together. Each rivet had to be heated, inserted, and hammered into place. It was time-consuming and required significant expertise. Welding was faster. A complete novice could be trained to perform simple welding tasks in little more than a week. Welding could also be done by machines in some cases, even faster than hand welding. And because welding didn't require overlapping steel plates, it saved steel, which was in extremely short supply. Kaiser took this modified design and built his shipyards specifically for mass production. He didn't adapt existing facilities. He created new ones from the ground up, designed around the principles of prefabrication and assembly line construction. The key insight was breaking the ship into sections. A Liberty ship had 1,200,000 individual parts. Traditional shipyards built ships by assembling all those parts on the hull, one piece at a time, with workers crowding around limited space. Kaiser's method was different. Major subassemblies, bow sections, stern sections, deck houses, engine rooms were built separately in dedicated production areas. These prefabricated sections could be built at waist height or upside down or on their sides, whatever position made welding easiest and strongest. Workers could access every angle. Quality control was simpler, and once the sections were complete, massive cranes would lift them into position on the hull, and welding crews would join them together. By April 1941, the U.S. Maritime Commission had formally approved mass production methods for what would become the Liberty ship. Construction began at multiple yards. Kaiser's Richmond Yard No. 1 laid the keel for its first vessel in April 1941. The SS Patrick Henry, the first Liberty ship, launched on September 27, 1941. It took 244 days from keel laying to launch. That was fast by traditional standards, but nowhere near what Kaiser knew was possible. Over the next year, his yards refined the process. They standardized components further. They improved the prefabrication systems. They trained workers more efficiently. They identified bottlenecks and eliminated them. By early 1942, construction time had dropped to 150 days. By mid-1942, it was down to 100 days. By the end of 1942, Kaiser's yards were completing Liberty ships in an average of 70 days. Some ships took even less time. The industry average would eventually drop to 42 days. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. But the real breakthrough came when Kaiser decided to prove what was possible. In November 1942, his Richmond Yard No. 2 assembled a Liberty ship as a demonstration project. The SS Robert E. Peary was built from keel laying to launch in 4 days, 15 hours, and 29 minutes, just under 5 days. Every step was coordinated. Every component arrived exactly when needed. Workers labored around the clock in shifts. The result was a fully operational 10,000-ton cargo vessel, completed in less time than it traditionally took to order the steel. The Robert E. Peary was a publicity stunt, requiring special preparation and coordination that couldn't be sustained. But it demonstrated the ceiling of what mass production could achieve. More importantly, it showed skeptics that the old methods were obsolete. The U.S. Maritime Commission eventually discouraged such demonstration projects as wasteful of resources, but the competitive spirit remained. Kaiser's yards competed with each other and with other shipyards. Oregon Shipbuilding, another Kaiser operation in Portland, built the SS Joseph N. Teal in 10 days. Richmond responded by building one in 13 days. The competition drove innovation and efficiency throughout the shipbuilding program. By 1943, Kaiser's 4 Richmond shipyards were producing ships at an average rate of 1 every 2 weeks. At peak production, the 4 yards could launch 3 ships in a single day. The Richmond yards alone would build 747 ships during the war, including 18% of all Liberty ships constructed. The workforce that made this possible was unlike anything seen in American industry. At peak employment, 42,000 people worked at Kaiser's Richmond yards. The vast majority had never built ships before. Many had never held industrial jobs. 65% were women. About 10% were African American workers who faced discrimination in hiring and housing, but were nevertheless essential to the effort. The youngest workers were 18 years old. The oldest were in their 60s. They came from farms, retail jobs, domestic service, and unemployment. Kaiser hired them because the traditional pool of skilled shipyard workers had been drafted into military service. He trained them through an apprentice school that could train up to 8,000 students per week. Classes ran continuously. Workers learned welding, riveting, sheet metal work, electrical systems, hydraulics, and quality control. The training was intense because aircraft and shipbuilding demanded higher standards than automotive work. A poor weld on a car frame was unacceptable. A poor weld on a Liberty ship could cause catastrophic failure in mid-ocean, killing the entire crew. Workers internalized this responsibility. They knew lives depended on their work. Moving these workers to and from the yards was itself a massive logistical challenge. Most lived in surrounding communities and traveled to Richmond by bus. Kaiser ran 165 private bus routes. Public transit added 35 more routes. Simply transporting 42,000 people to a rural shipyard every day required coordination that most cities couldn't manage. The federal government built housing adjacent to the yards. Bomber City housed 14,000 people at its peak. It had temporary housing units, schools, medical facilities, shops, and recreation areas. It was essentially a small town that existed solely to support ship production. The government also built the Willow Run Expressway, one of America's first limited-access highways to improve worker transportation. The Liberty ships themselves were simple by design. Each ship was 441 feet long and 56 feet wide. It displaced 14,000 tons fully loaded and had a top speed of 11 knots, barely faster than a person running. The three-cylinder reciprocating steam engine produced 2,500 horsepower, fed by two oil-burning boilers. 5 cargo holds could carry over 9,000 tons of cargo, plus aircraft, tanks, and locomotives lashed to the deck. A Liberty ship cost under $2 million, equivalent to roughly $35 million today. For that price, America got a vessel that could carry 2,800 jeeps, 440 tanks, or 230 million rounds of rifle ammunition. Each ship had a crew of 44 merchant mariners and 20 naval armed guards who operated the defensive guns. The ships weren't elegant, they weren't fast, they weren't particularly well armed. But they worked, and there were thousands of them. By the end of 1943, American shipyards had produced over 1,800 Liberty ships. By the end of 1944, the number exceeded 2,300. The final total would reach 2,710, with construction continuing through mid-1945, and Liberty ships were just part of American wartime shipbuilding. Between 1939 and 1945, U.S. shipyards built 5,777 vessels, including Liberty ships, Victory ships, tankers, and military vessels. The shipbuilding program employed 650,000 American workers at its peak in July 1943. The scale becomes clearer when you look at monthly production rates. At the peak of the war, the United States was delivering nearly 800,000 tons of shipping per month, roughly 70 times its average rate during the 1930s. For a brief moment, the U.S. was responsible for nearly 90% of worldwide shipbuilding. This massive wave of ships allowed the Allies to overwhelm Germany's submarine campaign, literally by building vessels faster than they could be sunk. In May 1942, German U-boats sank 325,000 tons of shipping. In July 1942, the total tonnage of Allied merchant ships launched exceeded tonnage lost for the first time in the war. After that point, the gap only widened. The Germans noticed. U-boat commanders returning from patrol reported encountering convoy after convoy. Formations of 80, 100, even 150 ships. Most were those same ugly cargo vessels, the ones that appeared in every theatre of operations. Italian submarine commanders operating in the Atlantic noted the same thing. Everywhere they looked, more ships. German intelligence struggled to explain it. There, analysts had calculated maximum American shipbuilding capacity based on peacetime production and traditional methods. Those estimates predicted maybe 200 to 300 ships per year under wartime conditions. When reports came back of yards launching multiple ships per week, intelligence officers assumed the reports were exaggerated. Surely American shipbuilding couldn't exceed German U-boat production by factors of 10 or 20. But it did, and the implications cascaded through German strategic planning. Donitz's calculations had been based on achieving a sinking rate that exceeded replacement rates. If Britain and America could build only 1,500 ships per year, and U-boats could sink 2,000, Germany would win within 12 months. But if the Allies could build 4,000 ships per year, or 6,000, the equation changed completely. By late 1942, German analysts were revising their estimates upward, but they still underestimated American capacity by significant margins. Part of the problem was conceptual. German shipbuilding used traditional methods with skilled craftsmen. A German shipyard might produce one vessel per month and consider that excellent progress. The idea that American yards could produce one ship per week, or 3 ships per day, seemed physically impossible. Albert Speer, Hitler's Minister of Armaments and War Production, would later write that one of Germany's greatest strategic errors was underestimating American industrial power. German leaders had looked at America's small peacetime military and concluded America was weak. They ignored America's massive industrial infrastructure, its engineering capability, its tradition of mass production, innovation, and its capacity for rapid mobilization. In his post-war memoir written in Spandau prison, Speer calculated that by 1944, a single American factory like Henry Kaiser's Richmond shipyard complex was producing more ships per month than entire German industrial regions. He wrote that Hitler's decision to declare war on America in December 1941 was the moment Germany lost World War II, not because of American military power at that moment, but because the declaration guaranteed that American industrial capacity would be turned fully toward destroying Germany. The Battle of the Atlantic reached its climax between February and May 1943. In March, Wolfpack sank 120 ships, totaling 693,000 tons. Dönitz believed he was on the verge of winning the tonnage war. But in May, everything changed. Allied convoy defences had improved dramatically. Escort carriers now accompanied convoys, providing air cover throughout the Atlantic crossing. Very long-range Liberator bombers closed the mid-Atlantic air gap where U-boats had previously operated safely. New radar systems could detect submarines on the surface at night. Improved depth charges and forward-throwing weapons made convoy escorts far more deadly. In May 1943, Allied escorts sank 41 U-boats, 25% of Germany's operational submarine force. 13 merchant ships were lost in convoy ONS-5, but 6 U-boats went down with them. The exchange rate had reversed. Instead of sinking 10 merchant ships for each U-boat lost, the Germans were losing U-boats at the same rate they were sinking merchants. On May 24, 1943, Admiral Dönitz ordered a temporary withdrawal from the North Atlantic. His U-boats retreated to safer waters. The Battle of the Atlantic continued, but Germany never regained the initiative. From June 1943 onward, more Allied ships were being built each month than were being sunk. The statistics tell the story. Between 1939 and 1945, U-boats sank approximately 3,500 Allied merchant ships, totaling 14.5 million gross tons. It was an enormous loss of vessels and lives. Over 30,000 British merchant seamen died, along with thousands of American, Dutch, Norwegian, and Greek mariners. 1 in 4 U-boat crewmen who put to sea never returned. Out of 40,000 Germans who served on U-boats, 28,000 died and 5,000 were captured. But while Germany was sinking 3,500 ships, American yards alone built over 5,700 vessels. Including British, Canadian, and other Allied shipbuilding, total Allied production exceeded 25,000 ships during the war. Germany couldn't sink vessels faster than they were being replaced, no matter how many U-boats Dönitz deployed. The final accounting is stark. Germany built approximately 1,181 U-boats that entered service. Of those, 785 were lost to all causes. At maximum strength in May 1943, only 118 were at sea. Simultaneously, out of 240 operational boats. The rest were in port for repairs, refitting, or working up new crews. In comparison, American shipyards built 2,710 Liberty ships alone. At any given time in 1944, there were thousands of Allied merchant ships at sea, carrying troops and supplies across every ocean. The disparity in numbers made German submarine warfare strategically irrelevant. Individual U-boats could still sink individual ships, but they couldn't affect the overall balance. By 1944, Allied planners worried less about submarine attacks than about port congestion from too many arriving ships. The Normandy invasion fleet in June 1944 included over 1,500 vessels. German U-boats sank only 8 of them. American Liberty ships unloaded continuously on the invasion beaches, disgorging cargo into smaller craft. The logistics that made the invasion possible depended entirely on having far more ships than Germany could ever sink. The same pattern repeated across every theatre. In the Pacific, American cargo ships supported island-hopping campaigns across thousands of miles of ocean. In the Mediterranean, Allied vessels supplied armies in Italy. In the Indian Ocean, Liberty ships carried supplies to the Soviet Union through Iran. Everywhere, the ugly duckling cargo ships appeared in numbers that overwhelmed Axis interdiction efforts. German U-boat production continued through 1944. New types appeared, including the revolutionary Type 21 electro-boot with improved underwater performance. But the advanced submarines arrived too late and in too few numbers. Only 2 Type 21s conducted war patrols before Germany's surrender. The outcome had already been decided by simpler mathematics: how many ships could be built versus how many could be sunk. The story has several endings, depending on perspective. For the U-boat crews, the ending came in May 1945, when Admiral Dönitz ordered all submarines to surrender. 156 U-boats surfaced and sailed to Allied ports. Another 222 were scuttled by their crews rather than surrendered. The once-feared wolf packs finished the war as museum pieces. For the Liberty ships, the ending took longer. 200 were lost during the war to enemy action, weather, and accidents. The rest served through 1945, then faced an uncertain future. Many were sold to shipping companies and formed the backbone of post-war merchant fleets. Others were laid up in reserve fleets, anchored in quiet bays as emergency capacity. By the 1960s, age and operating costs made them uneconomical. Most were sold for scrap. Today, only 2 Liberty ships remain operational: the SS Jeremiah O'Brien in San Francisco and the SS John W. Brown in Baltimore. Both serve as floating museums, maintained by volunteers. You can tour them, walk their decks, and see the cargo holds that once carried tanks and jeeps across the Atlantic. Standing on those decks, it's difficult to imagine that these simple vessels helped win the largest war in human history. For Henry Kaiser, the ending was complicated. He was forced out of Ford Motor Company in March 1944, just as his Richmond yards reached peak production. He received no official recognition during the war for his shipbuilding innovations. After the war, he went into other industries, eventually founding Kaiser Permanente Health Insurance. His shipyards closed in 1945 and were dismantled. The only lasting memorial is the Rosie the Riveter World War II Homefront National Historical Park in Richmond, which preserves some of the shipyard structures. The deeper ending is about what the Battle of the Atlantic revealed about industrial warfare. Quality matters, tactics matter, technology matters, but in total war, production capacity matters most. A force multiplier only multiplies what exists. If one side can build 10 times as many units, tactical superiority becomes irrelevant beyond a certain point. Germany understood submarine warfare better than anyone. They developed tactics that worked. They trained crews to a high standard. They built sophisticated boats with advanced technology. And they lost anyway because they were fighting an industrial war with insufficient industrial capacity. American shipyards outproduced German U-boat pens by such large margins that tactical excellence couldn't compensate. The lesson extends beyond World War II. It explains why strategic calculations must account for not just current forces but production potential, why accurate intelligence about enemy industrial capacity is as important as knowing enemy order of battle, why underestimating an opponent's ability to scale production has catastrophic consequences. German intelligence failed to properly assess American shipbuilding because they couldn't imagine anyone building ships the way Kaiser built them. Traditional shipbuilding was a craft industry. America turned it into mass production. That transformation, repeated across aircraft factories, tank plants, and munitions works, determined the war's outcome as surely as any battle. The U-boats prowling the Atlantic in March 1943 were hunting convoys. But the real battle was in places like Richmond, California, where welders worked 3 shifts building ugly duckling cargo ships at a rate that made German strategy obsolete. Those welders, many of them women who'd never held an industrial job before the war, were the ones who actually won the Battle of the Atlantic. They won it with welding torches and prefabricated steel sections. They won it by showing up to work every day and learning to build ships in weeks instead of months. They won it through mass production on a scale that Germany couldn't match and apparently couldn't even imagine. When Dönitz withdrew his U-boats from the North Atlantic in May 1943, he was admitting defeat not to British destroyers or American aircraft, but to American shipyards. Germany built 1,181 U-boats in 6 years. America built 2,710 Liberty ships before Germany even realized what was happening. And in that disparity lies the entire story of the Battle of the Atlantic. The numbers tell one story: 2,700 Liberty ships versus 1,100 U-boats. Production rates that overwhelmed German strategic calculations. Industrial capacity that transformed the Battle of the Atlantic from a close-run thing into an inevitable Allied victory. But numbers alone miss the human dimension. Behind every welded steel plate, every launched vessel, every cargo hold filled with supplies, there were people whose lives were permanently altered by the intersection of war and mass production. The story of how America built its way to victory is also the story of what that building cost. The Breaking Point Liberty ships had a fatal flaw that nobody understood until ships started breaking apart at sea. The SS John P. Gaines was steaming through the North Pacific in November 1943 when the crew heard a sound like a gunshot. A crack appeared in the deck, running from port to starboard. Within minutes, the crack had propagated the entire width of the ship. The vessel broke in half and sank in less than 20 minutes. 10 crew members died. It wasn't an isolated incident. The SS Schenectady was docked in Portland in January 1943 when it suddenly broke completely in two while sitting peacefully at the pier. No stress, no storm, no obvious cause. One moment it was a functioning ship. The next moment it was two pieces of scrap metal connected only by the cargo holds. Fortunately, the ship was empty, and nobody died. But the image of a Liberty ship cracked in half at dock shocked the maritime industry. Between 1943 and 1945, at least 12 Liberty ships broke completely in half. Several hundred more developed serious cracks that required emergency repairs. 3 ships suffered catastrophic failures that killed crew members. The Navy quietly began investigating what they called stress fractures, though initially they had no idea what was causing them. The problem was brittle fracture, a phenomenon poorly understood in 1943. Steel has a transition temperature below which it becomes brittle rather than ductile. When stressed while brittle, steel doesn't bend or deform gradually. It cracks suddenly and catastrophically. The crack propagates through the material at the speed of sound, traveling hundreds of feet in seconds. Liberty ships were particularly vulnerable because of how they were built. Welding created continuous steel structures with no barriers to crack propagation. In riveted ships, cracks would stop at rivet lines because riveted joints could absorb stress. But welded ships had no such protection. A crack starting anywhere could theoretically travel the entire length of the vessel. The stress concentration points were the square corners of cargo hatches. Under the flexing forces that all ships experience in rough seas, those corners acted as stress risers. A microscopic crack could form, then propagate through the hull when conditions were right: cold water, heavy seas, a ship loaded beyond its optimal stress distribution. Constance Tipper, a British metallurgist, identified the root cause. The steel used in Liberty ships had been selected for workability and cost, not for brittle fracture resistance. Under certain conditions, the steel became brittle at temperatures well above freezing. Combined with stress concentrations from welding and design features, the ships were essentially time bombs that could fail without warning. The solution involved multiple changes. Shipyards added steel reinforcement, straps around hatch corners to arrest crack propagation. They modified welding procedures to reduce internal stresses. They used different steel alloys with better low-temperature properties for critical structural members. Ships already at sea received emergency modifications during port visits. But the damage was done. Merchant mariners who'd already worried about U-boats, mines, and aircraft now had to worry about their ships literally breaking in half beneath them. The psychological impact was significant. Sailing the North Atlantic in winter meant knowing your ship might crack open and sink in minutes, not because of enemy action but because of how it was built. The Navy downplayed the problem publicly. Security considerations prevented detailed reporting. If Germany learned that Liberty ships had structural weaknesses, U-boat commanders would be ordered to target them preferentially. So the failures were quietly documented, ships were quietly modified, and crews quietly wondered if today would be the day their ship decided to break apart. The women who held it together, 65% of Kaiser's Richmond workforce was female. That statistic deserves unpacking. In 1940, fewer than 25% of American women worked outside the home, and most of those were in traditional female occupations like teaching, nursing, or domestic service. Industrial work, especially heavy industrial work like shipbuilding, was considered exclusively male. The idea of women welding steel plates or operating cranes was simply not part of American cultural consciousness. Pearl Harbor changed everything. The draft pulled 16 million men into military service. Defense industries needed to expand dramatically while losing most of their traditional workforce. The only available labor pool was women, many of whom had never considered industrial work as a possibility. Kaiser needed bodies more than he needed tradition. He hired women not because of progressive values, but because he had 42,000 jobs to fill and not enough men to fill them. What happened next was less about social revolution than simple industrial necessity combined with aggressive recruitment. The government launched a propaganda campaign to make factory work acceptable, even glamorous, for women. Rosie the Riveter became the iconic symbol, though the real Rosies were doing far more than riveting. They were welding, which was harder and more dangerous. They were operating overhead cranes that lifted 100-ton steel sections. They were working as electricians, pipe fitters, machinists, and quality control inspectors. The work was genuinely difficult. Welding requires holding position for extended periods while manipulating heavy equipment. A standard welding rod weighs several pounds. A welder might use dozens per shift. The work is done in confined spaces, in uncomfortable positions, often overhead or in corners where sparks rain down. The protective gear is heavy and hot. The arc flash is bright enough to cause permanent eye damage if you look at it unprotected. Women doing this work weren't playing at industry. They were performing the same tasks as men, often achieving higher quality ratings because supervisors claimed women followed instructions more precisely and took fewer shortcuts. Whether that was true or just another stereotype is unclear, but the production statistics don't lie. Ships built by majority female crews had the same quality metrics as ships built by male crews. The pay was substantial by standards of the time. Starting wage for shipyard workers was 60 cents per hour. Skilled positions paid up to $1.50 per hour. For women who'd been earning 25 cents per hour in retail or domestic service, shipyard wages were transformative. A woman working full-time at Kaiser's yards could earn $60 per week, equivalent to roughly $1,200 today. But the social costs were significant. Women working in shipyards faced constant skepticism from male workers who resented their presence. Sexual harassment was common and rarely punished. Many women reported being propositioned, grabbed, or insulted on a daily basis. Supervisors ranged from supportive to openly hostile depending on personal attitudes. Childcare was a constant challenge. The government built childcare centres near the shipyards, but they had limited capacity and odd hours. Many women worked swing shift or night shift when their husbands could watch children. Others relied on extended family or paid neighbours. Single mothers faced nearly impossible logistics. The housing situation was particularly difficult for African American women. Richmond's population exploded from 23,000 in 1940 to over 100,000 by 1943. Housing construction couldn't keep pace. Racial discrimination meant black workers were excluded from most housing options. Many lived in overcrowded apartments or temporary structures without adequate plumbing or heating. Despite these challenges, women continued showing up. They worked because they needed the money. They worked because they wanted to contribute to the war effort. They worked because, for many, it was the first time they'd had real economic independence. A woman earning $60 per week at Kaiser's yards wasn't dependent on a husband or father for survival. That economic freedom, however temporary, was transformative for many. The social impact extended beyond individual women. entire communities changed character. Richmond transformed from a quiet suburban town into an industrial boomtown with all the attendant social changes. Bars proliferated, crime increased. Housing shortages led to people sleeping in shifts in the same bed. Infrastructure designed for 20,000 people struggled to support 100,000. Schools were overwhelmed. The Richmond school system went from teaching 3,000 students in 1940 to 12,000 by 1943. Many teachers had left for higher-paying war work. Class sizes ballooned to 50 or 60 students. School buildings operated in shifts, with some students attending morning sessions and others afternoon sessions. Medical facilities faced similar strain. Richmond had one hospital with 50 beds in 1940. By 1943, the population had quadrupled, but hospital capacity had barely doubled. Industrial accidents sent a steady stream of injured workers to overcrowded emergency rooms. Women workers suffered injuries at rates comparable to men, shipyard work being dangerous regardless of gender. The accident statistics are sobering. Kaiser's Richmond yards recorded approximately 15,000 workplace injuries during the war, ranging from minor cuts to fatalities. 74 workers died in shipyard accidents between 1941 and 1945. The most common fatal accidents involved falls from scaffolding, being struck by moving cranes, and electrocution. Women represented their proportional share of both injuries and fatalities. One particular accident highlighted the dangers. In November 1942, a crane operator misjudged the weight of a bow section being lifted at Richmond Yard 2. The crane tipped forward, dropping the 100-ton section onto workers below. 6 people died instantly, 3 men and 3 women. 14 more were seriously injured. The accident investigation found no fault with the crane operator. The equipment had simply been operating at the edge of its capacity, and a small miscalculation proved fatal. The end of the line. The last Liberty ship, the SS Albert M. Bow, was completed in October 1945. By then, the war had ended. Japan had surrendered. The massive industrial mobilization that had produced 2,700 Liberty ships in 4 years was no longer needed. Kaiser's Richmond shipyards received termination notices for their government contracts. Production stopped almost immediately. Workers who'd shown up for years suddenly had no work. The layoffs began in August 1945 and continued through the fall. By December, fewer than 5,000 workers remained, down from a peak of 42,000. For many women, the end of shipyard work meant a return to pre-war life. Societal pressure pushed women out of industrial jobs as returning veterans needed employment. The Rosie the Riveter, who'd been celebrated as patriotic, was now told she needed to return home and make room for men. Many women were fired outright. Others faced pressure to quit. The jobs that had provided economic independence and decent wages disappeared. Not all women went quietly. Some fought to keep their positions. Union records from 1945 and 1946 show disputes over seniority rights and discriminatory layoffs. Women argued they'd gained seniority during the war and deserved protection equal to male workers. Management and unions generally disagreed. By 1947, female industrial employment had dropped back to near pre-war levels. The African American workers faced additional challenges. The wartime housing that had sheltered black families was temporary, built for the duration. After the war, much of it was demolished. Black workers who'd migrated to Richmond for shipyard jobs now faced unemployment and housing shortages simultaneously. Many left Richmond. Those who stayed faced the same discrimination that had existed before the war, but now without the desperate labor shortages that had forced some acceptance. The shipyards themselves were dismantled. The massive cranes were cut up for scrap. The prefabrication facilities were torn down. The ways where ships had been launched were cleared. By 1947, almost no trace remained of the industrial complex that had produced 18% of all Liberty ships. Richmond's population crashed. From over 100,000 at peak, it dropped to 70,000 by 1948. The boomtown economy collapsed. Businesses that had thrived on shipyard wages closed. The social problems that had emerged during rapid expansion, crime, overcrowding, inadequate infrastructure, didn't disappear immediately. Richmond spent decades recovering from the boom-bust cycle. For the ships themselves, peacetime brought mixed fortunes. The best-maintained vessels were sold to commercial shipping companies. Liberty ships formed the backbone of post-war merchant fleets for nations rebuilding from devastation. Greek shipping companies bought hundreds at bargain prices. They were slow and basic, but they were cheap and available in quantity. The rest went into reserve fleets. The National Defense Reserve Fleet anchored hundreds of Liberty ships in quiet bays where salt water and time slowly corroded them. The idea was to maintain emergency shipping, capacity for future conflicts. In practice, the ships deteriorated steadily. By the 1950s, many were beyond economical repair. The Korean War briefly revived some ships. Between 1950 and 1953, over 600 Liberty ships were reactivated from reserve fleets and returned to service. They carried supplies across the Pacific, proving that even decade-old emergency cargo vessels could still function when needed. After Korea, most went back into reserve. The final chapter came in the 1960s and 70s when age and economics made continued preservation pointless. Most were sold for scrap, cut apart in shipbreaking yards around the world. A few were used as breakwaters, deliberately sunk to protect harbors. Others were used as target ships, finally destroyed by the weapons they'd helped deliver. The accounting historians love to calculate comparative costs and benefits, reducing human struggles to economic metrics. In those terms, the Liberty ship program was extraordinarily successful. 2,700 ships for $5 billion, roughly $2 million per ship in 1940s dollars. Those ships carried 75% of all cargo shipped overseas during the war. But what did it actually cost? Not in dollars, but in human terms? 74 workers died building Liberty ships at Richmond alone. Across all shipyards, hundreds more died in construction accidents. Thousands were permanently disabled by industrial injuries. The exact totals aren't precisely documented because safety reporting was inconsistent during the war. 200 Liberty ships were lost during the war. Approximately 2,200 merchant mariners died on Liberty ships, sunk by enemy action. Several hundred more died when ships broke apart due to structural failure. The true total is uncertain because maritime casualty records from wartime are incomplete. The hidden costs are harder to quantify. How many women who'd gained economic independence and skills during the war spent the rest of their lives wondering what they might have achieved if society hadn't pushed them back into traditional roles? How many African American workers who'd experienced relatively good wages and treatment, however imperfect, returned to communities where discrimination was absolute? The environmental costs weren't calculated at all in the 1940s. Richmond's shipyards dumped industrial waste directly into San Francisco Bay for years. The contamination persists today. The cleanup has cost hundreds of millions and isn't complete. That's a debt the 1940s generation left for later generations to pay. The psychological costs affected everyone involved. Veterans returning from war found their jobs taken by people who'd stayed home. Workers who'd supported the war effort by building ships were laid off unceremoniously once they weren't needed. Communities that had been transformed by industrial mobilization struggled with the aftermath. Kaiser himself made a fortune from government contracts, though he reinvested much of it in other ventures. The workers who'd actually built the ships got severance pay and memories. Some received preferential hiring at Kaiser's post-war businesses. Most returned to whatever life they'd had before, or tried to build new ones from scratch. The last word. In 2024, the SS John W. Brown sailed from Baltimore to participate in a ceremony commemorating the 80th anniversary of D-Day. The ship is 79 years old. It's maintained by volunteers who spend weekends keeping a World War II freighter operational, using original equipment and replacement parts fabricated from scratch. Walking the decks of the John W. Brown provides perspective that statistics can't capture. The ship is smaller than you'd expect. The cargo holds are cavernous, but the crew quarters are cramped. The engine room is a maze of pipes and valves. Everything is manual. Everything requires constant maintenance. Everything reminds you that this was built as a disposable emergency vessel, expected to make a few voyages before being sunk or worn out. That this particular ship survived for 80 years is almost accidental. That 2 remain operational is a minor miracle. That 2,700 were built in 4 years is the story we remember. But the story we should remember is more complicated. Yes, American industrial capacity overwhelmed German submarine warfare. Yes, mass production techniques revolutionized shipbuilding. Yes, the Liberty ship program was a triumph of logistics and engineering. All of that is true. But it's also true that the triumph was built by people who were exploited, however necessary. Women were paid less than men for identical work. African Americans faced discrimination in hiring and housing while building ships for a war allegedly fought for freedom. Workers were injured and killed at rates that would be considered criminal today. Ships broke apart and killed crews because production speed mattered more than thorough testing. The Liberty ships won the Battle of the Atlantic. They also represent America's willingness to mobilize everything and everyone toward a goal, regardless of cost. Whether that's admirable or horrifying depends on your perspective, and probably on whether you were one of the people mobilized. What's undeniable is that it worked. Germany built sophisticated weapons with skilled labor using traditional methods. America built simple weapons with inexperienced labor using mass production. Germany calculated that quality and skill would triumph. America proved that quantity, delivered fast enough and in sufficient volume, would overwhelm any qualitative advantage. The lesson echoed through the rest of the 20th century and into the 21st. Industrial capacity matters, production speed matters, the ability to mobilize and train massive workforces matters. The willingness to sacrifice everything for victory matters. The Liberty ships taught us that wars are won in factories as much as on battlefields. They taught us that traditional methods can become obsolete overnight when someone questions assumptions. They taught us that ordinary people, given training and purpose, can achieve extraordinary things. They also taught us that victory has costs beyond the battlefield. That mobilization creates social changes that outlast the crisis. That boom-bust economic cycles devastate communities. That some debts get paid by later generations. Standing on the deck of the SS John W. Brown, watching volunteers maintain equipment built when their grandparents were young, you can see both sides of the story. The triumph of building 2,700 ships in 4 years, and the human cost of building them. Both stories are true. Both deserve to be remembered. The ugly duckling cargo ships that won the Battle of the Atlantic were neither pure triumph nor simple exploitation. They were both, simultaneously, an achievement we should study and a cautionary tale we should heed. That complexity, more than any production statistic, is the real story of the Liberty ships. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.